let people catch up as they join us, but I'm going to put these notes. The notes are in Google Classroom, so if you're one of those like to print it out and follow along, they are there. Otherwise, I'll have it up here on the screen. You can write it on paper if you want to take notes that way. However you like to do that, whatever works best for you and your learning. So we're looking at reciprocal functions. Reciprocal functions. So let's look at the parent function. Would just be f of x equals 1 over x. That's a reciprocal. That's a reciprocal of x is 1 over x. Now let's look what the graph of that would look like. I'm gonna graph it with like a darker, like a pen right here. So it's one of those graphs that comes down and then turns and goes this way. But there's also the negative side of that. The negative side comes and goes down there. So that's what the graph of 1 over x looks like. That's the reciprocal function. So you'll notice it doesn't touch the y-axis and it doesn't touch the x-axis with just the 1 over x. Because if it touched the x-axis, that would mean, or touched the y-axis, that would mean x is 0. Well, 1 over 0 does not exist. That is not a number. That is as an error in your calculator, 1 divided by 0. We can't divide by 0 because that's when the Earth explodes and we're all thrown off into space. Well, maybe nothing that bad happens, but it just doesn't work. So that's why this doesn't ever touch the y-axis. Now, why does it never touch the x-axis coming down? Well, how big a number do we have to make x? How far do we have to go before the function equals 0? A billion? Well, 1 divided by a billion is still not 0. It's a very, very, very small number, but it's not 0. It doesn't matter if this is a quadrillion, trillion, billion, million. Still, it's not going to be 0. 1 divided by that, it's going to be an incredibly small number, but it's not 0. So it never makes it down to 0. And it never has x equals 0 because you can't do that. So there's a vertical asymptote. Remember, vertical is up and down. There's a vertical asymptote at x equals 0. Cannot be 0. There's a horizontal asymptote at y equals 0. It never gets down to 0 as a value. The domain would be all the possible x's. Well, here's an easy way to write that. It basically goes from negative infinity to infinity, but x cannot be 0. That covers everything then, because this goes on forever. So negative infinity, this goes on to infinity. So it covers every number between negative infinity and infinity, except can't equal to 0. So that's the easiest way to write that. You can also write that negative infinity to 0 with a parentheses, which means it doesn't include that. So then you have to also union that with 0 to infinity. This is the same thing. Negative infinity to 0 and 0 to infinity. But you would not use the bracket. The bracket means you include the 0, and it's not included. So we use the parentheses. But this is probably easier. From negative infinity to infinity, except x can't equal 0. The range, all the y's, same thing. Negative infinity to infinity, except y can't equal 0. And that's for the parent function. Now, transformations of that will affect that domain and range because it'll move. So let's look at what the standard form of the reciprocal function looks like. F of x, it could be any number. It doesn't have to be 1 on top. It could be any number. We'll just call it a over x minus h, because h will affect left and right. And then plus k. K will move it up and down, right? Whether k is positive or negative. So let's look at that. So h is the horizontal. I got this line. The printer made this line. It's not on the original document. That's the horizontal shift. If it is a plus, Right, so x is a positive. I mean, sorry, we'll look at h. If h is a positive number, like let's say it's 5, so you got x minus 5, that's going to shift left if h is a positive number. If it's a negative number, it's going to shift it to the right. All right, the k is at the end. That is the vertical shift. So a positive number raises everything up, it shifts up. A negative number shifts down. So it works just like the transformations we had on the other functions that we looked at earlier in the year. So that A right there, if it's not 1 over, maybe it's a negative 1. It could be a negative 1. If A is a negative, then the function is reflected across the x-axis. Technically, but not technically, it's really reflected downwards. It's not necessarily over the x-axis, but for the parent function, it would be reflected over the x-axis to where it would be over here and up here. That would be the negative 1. Okay. So the absolute value of the A doesn't matter if it's positive or negative. If it's a bigger number than 1, if it's 4, if it's negative 11, whatever, that's a vertical stretch, which means this is going to be way up here instead. All right, to move that up there, it's going to be a vertical stretch up into this area. It's going to make things bigger. Or other direction if it's a negative. If it's between 0 and 1, then it's a vertical shrink. Right, it pushes it down closer to the x-axis quicker. So the vertical asymptote with this standard form, the vertical asymptote is equal to x equal whatever h is. If h is a positive, that's what the vertical asymptote is going to be. If it's a negative, that's it. And the horizontal is y equals the k. So that's the primary notes that helps you get through reciprocal functions. If you know this stuff right here, then we can do some work with it. So let's practice a couple items here. All right. So let's use this example. Turn this light on, maybe we'll see a little bit better. F of x equals 1 over x plus 1 minus 5. So let's identify what our h is, and let's identify what our k is. Because it's x minus h. And x minus h equals 1. Oh, the positive 1. So if x minus h equals 1, then that means the h must be negative 1. I'm sorry. If it's x plus 1, let's do this. X plus 1 is what is equal to the x minus h. So if it's a plus 1, that must be minus a negative 1, which means the h must be negative 1. That's the only reason it ended up a positive. It's because when we subtracted h, x minus h, when we subtract h, it must be a negative 1 to be with x plus 1. And the k is right here in the end. It's a minus 5. So our k is minus 5, or h is negative 1. It wants us to graph this. We're going to do that. We're going to look at it on Desmos. But first, let's fill in the vertical asymptote. Well, we said in our notes, that's x equals h. So there should be an asymptote at x equals negative 1. And there should be a horizontal asymptote at y equals negative 5. So let's put this on Desmos and see what it really looks like. All right, here's Desmos. We're going to graph this equation. F of x equals 1 divided by x plus 1 minus 5. All right, here's the graph. Let's zoom out a little bit. We'll see a little better. So we said there should be a vertical asymptote, that's up and down, at x equals -1. Look at that, -1. See, our asymptote's moved over to where it'll never touch -1. And then the y equals -5. Well, we can see that it doesn't touch -5. It gets closer and closer and closer to it. Starts up here at -4, -4.6, -4.8, -4.9, and it'll keep going and getting smaller and smaller. So that is correct. And let's go ahead and just draw that onto our graph just to have that.
Yeah, I was going to ask you about that, Lily, because you're on.
Then this one goes.
So I wasn't sure about that. I think it's just for the spheres.
All right.
We'll have
I'll show you that.
Yeah.
So drawing that on there, we've got that asymptote at -5 that never touches, and another one at -1. So that's our two asymptotes. What is the domain? All the x's that are possible. Well, it goes from -infinity to infinity, except x cannot be -1. It'll never touch -1. The range, -infinity to infinity. The y cannot be
Okay. Oh, yeah.
-5.
No, I'm sorry. No, I don't know if I explained that correctly. Yeah.
So that's not so bad.
Like,
Gave us the equation. We were able to get the asymptotes. We were able to get the domain and range and saw the graph of it right where we expected it to be. Let's try another one. Oh, this one does not have a 1. It has a -2. -2. So let's see what that does on the graph. We can see what the h is, x plus 3. So our h is -3 because x minus -3 would be x plus 3. The k, look, there's nothing out here. Our k is just equal to 0. So we expect to see an asymptote up and down at -3 and still at 0. But let's grab this and just see what happens to it when we have this. Let's take this off first. I want to go back to just 1 over x. All right, so that's just the 1 over x. That's the original one that we looked at first. Let's put that negative on there. Look what happened. It just reflected down. Instead of it being up here, now it's underneath the x-axis. Everything turned over. This part that was up here moves below the x-axis, reflects it over the x-axis. But it's not a true reflection. Let me tell you why it's not a true reflection. Let's say it's at +3. If it's up here, if it were to reflect over, this asymptote would move down here to -3, right? We put that negative on the front. See, the asymptote stays up here. It's not really a reflection over the x-axis unless you look at it at the very, very first thing that happens. The very first thing that happens is that it does reflect over the x-axis. I'm going to put that negative on there. Then it moves up to 3. So it's not a true reflection, but it does reflect downwardly. It turns it over. It flips it upside down. But we say it reflects over the x-axis in our notes here. But let's see. We want to look at this -2 to see what that did. First thing is it flipped upside down. Now let's see what the -2 does. Changing that 1 to a 2. Oh, see it? It moved a little higher. It used to cross. I'm going to put it back at a 1. Here, I'm going to put the other one there. Put the original one here. Equals 1 over x. That's the original one. And notice it goes through at 1, 1. If we change that to a 2, now it goes to 1, 2. It's twice as tall. It stretched it upwards. Instead of being down at 1, it moved up to 2. And then when we put the negative on it, it moved it to -2. -2. So the 2 is a stretch, but it does not change the asymptotes. So let's go ahead and put the whole equation that they gave us. Take that one off. -2 x plus 3. So we're going to put that +3 in with the x. So when we back it out and look at it, we've still got that y equals 0. We said that would be the asymptote. And now the x equals -3. I can put that line on here. X equals -3. There it is, the green line. That's an asymptote. It never touches that at x equals -3.
So they probably evolved.
All right.
About 300
So the vertical asymptote is, not h equals x equals -3, and still at y equals 0, because that's what h and k are. And the domain, notice the domain goes right with the asymptote. -infinity to infinity. X cannot be -3. We pull that number straight off of the asymptote. -infinity to infinity. Y cannot be 0. So notice, that's the asymptote. So that's what x cannot be. That's the asymptote. That's what x cannot be. Because it's an asymptote. It never touches that one. Same thing with the y. That's the asymptote. Y cannot be that number. 0. Y cannot be that number. So that's how that works. So I want to try a problem with you. Let's look. I've got a problem over here I want to look at. All right. I still have the vertical horizontal asymptote notes on this page. What if I give you the translation and you write the function? Because the reciprocal parent function is translated 4 units right. Okay, so that's important to know. 4 units to the right and 3 units down, and then reflected across the x-axis. And they want us to write the equation. We have to write that equation. All right, we can do that. So let's start with our function. We know it's reflected, so there's going to be a negative out there. It does not say anything about a stretch or shrink. This one's stretched. This one is not, so it's just a 1. So I need to make sure that negative is not touching. I can put the negative out in front or with the -1. Doesn't matter. It's the same thing. Whether it's over here or over here, it's the same thing. 4 units right. It's going to the right. Well, let's go back and look at our notes. H, when it's a negative, shifts to the right. So the H will be a negative. So it's x minus -4, because it went right. Wait, did I do that right? Positive shift left, negative shift right. H is horizontal. Oh, I may have that backwards, because look at this. The H was negative and it went left. We've got these backwards. I was thinking of the x minus. It was minus, it shifts right. Let's fix these, guys. Fix our notes. Because this is a negative H and it shifted left. When we see a negative here, it shifts right because that means H is positive. That's the confusion. If we see a negative in the equation, that means the H is a positive and it shifts to the right. So since this one shifts to the right, it is going to be a negative in the equation. It'll be x minus 4. We should see a negative in the equation to shift to the right. And 3 units down. So subtract 3 at the end. So this is our equation. We've written the equation to represent 4 units to the right, 3 units down, and there. All right, let's try another one. Since we messed that up, let's try another one. Okay, this one goes up 7 units. 1 unit left, vertically stretched by a factor of 2. So it's going to be a 2 because of the vertical stretch. It goes left 1 unit. This one went right. If it goes left 1 unit, that'd be x plus 1. X plus 1, because that means that H is -1. H equals -1. That would shift it 1 unit to the left. And 7 units up. Plus 7. So that is our function. That is the equation that we're doing right there. All right. Let me see. Is there anything else we need to do? Oh, yeah, one more. Here, I'm just going to do this on the back of this. Let's say I just give you the asymptotes. Asymptotes. Wonderful word. It's the only word out there that's only a math word. It's not used in any other context other than mathematics. So if I say you have an asymptote at x equals 4 and another asymptote at y equals negative 6, can we write the equation? All we know is the asymptotes. That's all we know. Absolutely, we can do that. 1 over x. Is our x going to be positive or negative? It's x equals 4 is our asymptote, so that should be when it's x minus 4, because that's over to the right 4 units. Negative 6. Negative 6. Whatever the y is, just goes right here on the end. Let's look and see if we're right. We can do that real easy. We can double check ourselves by going here and graphing what we just wrote. We wrote 1 divided by x minus 4 minus 6. Oh, get it up here. Minus 6. Okay, what asymptotes do we see here? There's an asymptote at x equals 4. And there's an asymptote at y equals negative 6. There's the two asymptotes. X equals 4, y equals negative 6. What were we supposed to write? X equals 4, y equals negative 6. So that equation is correct because it does have those two asymptotes. And that's what we were asked to do. Here's the asymptotes, give me an equation. So this is the h, that is the k. Just put them into the equation right where the h and the k go. All right, that's it. I just decided this morning that we were only doing reciprocals this morning. We're going to save everything else for next week. We're going to take a little bit of a breather and just do the one reciprocal lesson this time. So you have the assignment, informative. All right, here it is. I say 14 problems, but here's the first one. Write an equation to represent this function. Translate 2 units down, 2 units left and 9 units down. Now I gave you up here at the top of the screen the parent function and what the standard form is. You know, 1 over x is what it looks like just without any translations, without any transformations at all. Then here's the form you need to use, the x minus h plus k with the a. So you would write the new equation right there. And then it asks you, what's the asymptotes? And I give you multiple choice. X equals and y equals. What are the asymptotes for that equation you just wrote? It's 2 units left and 9 units down. Then here's another one. Write that and choose those two. Write that, choose those two. So you got multiple choice on the asymptotes. All right, that's the first 6 problems. Here's one like we just did. I'll give you the 2 asymptotes. You write the equation. I'm giving you 2 asymptotes. You write the equation. And then the last page, I'll give you the equation. Tell me the domain, the range, and the asymptotes. And the asymptotes, you just type them in right here. Then the domain, the range, and the 2 asymptotes for this equation, and that's all it. So it says 14 problems, but it's not. Like, you know, here's 6 problems right here, but it's just 2, really. You're telling me the domain, the range, asymptotes of these 2 functions. And this is just negative 1 over x. So, all right. Hopefully you can handle that. If you have questions, have problems, please email me or come to class Wednesday or Friday. This is an A Friday. So if you need help, please come get some help on that. If you're behind on work, get that turned in. I'm going to be grading over the next day or so and trying to get the grade book updated as quick as I can because I know you guys have put a lot of work in lately. I've seen a lot of things turned in. And that Unit 4 test, I basically have to grade everything on the test we just had. Because formative just, they're terrible. It's terrible at grading equations. It can grade a lot of things, but equations and stuff, it's not good at. So I have to grade all that by hand. So they'll be a little slower, but I'll get that in there as soon as I can. So, all right, guys. Email me if you have problems. Have a great week. It's May. We're getting close. Just hold in there a little bit longer. We'll see you next time.